it's relatively lengthy, as I told you. When it comes to the sine and cosine rule, normally, um, normally we're asked to prove those for CXC. So it is best that you learn these as best you can. So again, the cosine rule is not a right angle triangle. If you have a right angle triangle, you cannot utilize the sine nor the cosine rule. So I'm gonna call this A, I'll call this B, I'm gonna call this C. All right, so here we have a obtuse angle triangle. And what I will be doing is, obviously, I can't, as I said, we can't use Pythagoras nor trigonometry if it's not a right angle. So I'm going to take and I'm going to make this a right angle triangle. I'm going to extend it, right? So this is D, all right? Note one thing though, from the original triangle, this is side A, this is side B, and this is side C. You'll need to know this as we go along. So I'm just putting it there. Now, if we're looking at Pythagoras' theorem, let's start with what we do not have. What is imaginary? What we put there for use, for our personal use. So I'm gonna be, first I'm gonna consider triangle BCD, triangle BCD, and I'm gonna be using Pythagoras's theorem on it, his stolen theorem. So that means that I'm gonna have that D squared is equal to C squared plus B squared. Obviously, D squared is side E. So A squared is equal to this imaginary C, which I'm gonna call BD squared, plus this side, which is imaginary B, which is CD squared. Everybody with me? Guys, are you with me?
Yes, sir.
All right, now, the next thing I'm going to do is I'm going to consider now this right here, the whole big right angle triangle. Right? So I'm gonna say, I'm going to be using Pythagoras again. So this was, you can see this is step A. So this will be step B. So this time I'm gonna consider triangle ABD. And ABD then, using Pythagoras, because cosine rule is actually a derivative of Pythagoras' theorem, we know that the hypotenuse for this, since this is the right angle here, so the hypotenuse is AB, so AB squared is equal to BD squared plus AD squared. Now the problem with this is that AD has a real part, which is this part, and it has an imaginary part, which is the other part, which is this part right here. So that's the imaginary part and that's the real part. So I need to work that out. I need to deal with that, all right? So I will say that A, AB squared is equal to, well, BD squared plus AC plus CD squared, right? AC being the real part and CD being the imaginary part. Everybody with me so far? Guys?
Yes, sir.
Yes, sir.
All right. Now that we have that into consideration, This piece right here, I'm gonna even put it in a different color. This piece right here is following a different rule. All right. So I will say that I'm gonna need to be using a plus b squared, which is a squared plus 2ab plus b squared for this part right there. Okay, which will give me then ab squared is equal to bd squared plus ac squared plus 2ac times cd plus cd squared. Everybody with me? Did I lose anybody?